Good morning, everyone. I'd like to thank everyone for coming out this Saturday morning, especially time of year when your trees are starting to bloom, and I know that's a beautiful sight for a lot of you guys. I'd like to thank Carrie Houston for inviting me today, and the Texas Live Growers Association Council as well. My name's Noel Garcia. I'm with the Texas Plant and Soil Lab. I'm the Vice President and Technical Director for the laboratory. Actually, Texas Plant and Soil Lab is the oldest soil testing laboratory in the state of Texas, dating back to 1938, over 78 years in business. We are an international laboratory and consulting laboratory. We do work from Ireland, working with carrots in Ireland, to say parsnips in Germany, citrus in the Rio Grande Valley, to row crops in Mexico. You name it, we've done it. Uh, let's go ahead and start off here. I want to show this. This is a Saviano tree that I was approached by a landscaper who they actually transported this Saviano tree from California and was planted in Corpus Christi. And anybody care to take a guess at how old that tree is? Just look at that trunk. It's amazing how big it is. But anyway, that's got to be about 100-plus-year-old tree. When they approached me, you can hardly tell there, but the leaves were turning a little bit yellow and so forth. Had some major nutrient deficiencies and a little bit of stress from after the transplanting that occurred. But after we did a soil test, leaf analysis, we were able to help them with that problem. Today, basically, I want to start about how what a good nutrient management and irrigation schedule would be for your olive grove orchard. So let's go ahead and start off with what are some tools for optimal nutrient management here. Of course, observation of trees and environmental conditions is always a must. I can't stress enough how important it is for you all to walk your orchards on a daily or weekly basis and just take some notes down. Look for some abnormal symptoms in foliage and growth and jot those down. Time of the year you've noticed those and on what different varieties, because you can see some even varietal differences in there as well. Make sure and look for other observations such as deficiencies, such as chlorosis or some of these other margin leaf burn or some of these deficiencies, which I will be discussing in detail here through my presentation. Some tools for optimum nutrient management, of course, also include soil and water analysis. You want to start off with a soil audit, which will help determine what your pH is and what your nutrient needs are as well. Uh, this helps determine if, say, your pH is too low, we might have to recommend a lime application. Or if your pH is significantly high, strongly alkaline, then something like sulfur will be recommended. Also determines any nutrient deficiencies or toxicities that can be addressed as well. It's a number of times that we have found where if they only tested topsoil, everything was okay, but we went ahead and asked for a subsoil analysis as well and found out to have some toxicities, especially sodium here in the state of Texas. There are some areas that are predominantly high in salt or saline conditions. So that's something that we need to start addressing as soon as you plant those trees, not when you start seeing some toxicity effects. 3-4 years later after it's been planted. Helps determine also the base of your fertility program for the season. Of course, it's always good to plan ahead and see what your nutrient needs might be, but that's not a 100% program that will be used, and those may be adjusted in season according to a plant analysis as well. Water analysis also helps determine how to properly manage that irrigation water, whether it is too salty or maybe it's in good salt conditions, but maybe it's a little bit too hard for your spraying to used to be as a foliar spray. So these some of the analysis that highly recommend you doing in your orchards time to time. Uh, Also, another tool is the leaf analysis, like I mentioned previously. Initial leaf analysis should be done on 2-year-old trees. We really want to start off early, have those trees in a nice, healthy, stress-free environment by balancing all the nutrients in the trees. Of course, when they're young like that, they don't require as much nutrients as they are when they're in a stressful situation come when they're in full production. So I'll be talking about the differences there. Uh, One of the questions I get asked all the time is how often should we test the trees? I recommend regularly, at least 2 to 4 times a season. Another question I'm being asked, well, what time of the year should we sample? The data out there shows that you ought to test that at fruit set. Well, yes, that's important. But after fruit set, we've already set the genetic potential of that tree. So why not test earlier, right at before pre-bloom or at bloom, so we can increase our yields and quality early on. And I'll be going into some details as far as what other times of the season are important there through my presentation. But at least two, maybe four would be better. Samples should be taken from similar trees. I've gotten samples in the laboratory that they just cut a limb off of one tree. Well, is that truly representative of what's out there? Now, if that's only a Arbequina and you've got some other varieties in there, is that fertility recommendation off of that one limb, off of that one variety, uh, good enough for the other varieties? May or may not be. Make sure and also you sample the same soil type. If you got different soil types out in an orchard, got to make sure that we separate those samples, especially when it's coming to a different soil type. Results will help make in-season adjustments, again, to maximize the tree's genetic potential. We're trying to get as much production off of those trees, but meanwhile, trying to increase your oil production and quality of that oil as well. Some factors influencing some photosynthesis. I'll be going to photosynthesis here in the next few slides, and it's very important. And I'll tell you why. Of course, I was at your fall talk earlier, or latter part of last year, where you had the gentleman from Spain talking about pruning, and this is why. Light interception is important. You realize that only leaves on the outer edge of the canopy are ever exposed to full sun. So light is limited inside the canopy. So what happens when your light is limited? Well, your photosynthesis that should be occurring will be limited. Your carbohydrate production will be to a minimum, and which is essential for use in fruit development. So light management is essential to maximize your yield. If you don't prune those trees annually, then you don't have enough light going off on that canopy, which will cost you production. So again, control with good pruning management, as well as irrigation and fertility, and I'll tell you why. Other factors that influence photosynthesis are temperature. Photosynthesis is optimal in olives at temperatures between 59 degrees and 86 degrees. Well, sometimes that, depending where you're at in the state, that can vary. But those are just optimal. Those can be also influenced by nutrient supply. For example, phosphorus plays a vital role in energy transfer and metabolism. Uh, if it's not in a readily available form, or if you applied it in the wrong form when you got high pH in your soil, then most likely it may tie up if you're applying it very early in the season, but your need for phosphorus is, say, in early bloom, say in March or April. Iron and manganese, molybdenum, and zinc also help regulate enzyme activity, so it's very important to sort of balance those out. Any one of these deficiencies, any of one of these elements can result in chlorosis and limit photosynthesis. Water supply, water is very important for the trees. Water stress limits photosynthesis by directly affecting the photochemical processes involved or by causing the stomata to close, which limits your carbon dioxide availability. Uh, if you stress those plants too much, that stomata will be constantly closing or very limited, and then you'll be affecting photosynthesis or carbohydrate production, which is affecting your yield overall. Your typical olive leaf with good sun exposure on a summer day, the stomata opening increases, light intensity increases, reaching its maximum by mid-morning. So afternoon temperatures may be excessive and stomata may narrow or close to prevent water loss. Of course, if you don't water at optimal times to keep up with the demand, it will cost you production as well. And by the way, also quality. And I'll be talking about some of those quality factors as well. So, olive true root system, how deep are those? So, olives are commonly planted in shallow soils. Roots are frequently restricted to the top, say 3 or 4 feet. Even in deeper soils, they tend to remain in shallow rooted. So, approximately 70% of the roots are in the top 2 feet. So you guys live in a hill country, they have a shallow, they might do well, they fairly well. But of course, shallow root means that your water evaporation might be a lot quicker. So you got to make sure and keep optimal levels of moisture in that soil since it's very shallow rooted. Some of the environmental effects on roots, it's not enough moisture is one of the issues, especially here in the state of Texas. We've been coming in and out of drought conditions and really affects the overall health of that tree. So readily available moisture is necessary for root activity. Uh, Roots do not grow through a dry soil, and their exploration for available resources is limited under some of these conditions. Uh, Movement of nutrients to roots is slower with low soil moisture. There's a lot of nutrients that transfer via flow. So if you don't have moisture to transfer those roots, then the uptake will be minimized. For example, potassium. A lot of times in a leaf analysis, when your potassium is low, it's not necessarily due to lack of potassium in the soil, but lack of available moisture, which flows the potassium into your major root feeder roots, which will uptake those nutrients. So you got to be careful and make sure you keep optimum moisture. Now, on the other extreme, too much moisture, and we've got some times where we might overwater, or we get a heavy rain shower, a few inches, and we continue to water. Under these conditions, too much water in soil can be damaging just as bad as too little water. Of course, olives are very sensitive to water excess and subsequent lack of oxygen. Uh, Having that too much water in the soil, of course, leads to anaerobic conditions, and these anaerobic conditions strongly influence root pathogens such as root or crown rot, or even harmful nematodes that can affect your trees. So we got to make sure and don't overwater. Little side note here, terminals for new roots can be killed in 1 to 4 days in a completely saturated soil. So we got to be careful and make sure and monitor the amount of water we're using. Uh, be surprised how often I get called out to some orchard, whether it be a vineyard or olive, and I've asked them, if they were tested their quality of their water. Never have. So highly recommend, even before you start, or you have never done it, go ahead and take a sample and submit it to the lab and run a water analysis on it. Because excess salts can really be a potential problem, especially irrigated trees. So, for example, high levels of sodium, chloride, boron, and sometimes sulfates in the soil or irrigation water can cause these ions to accumulate in the tree and ultimately cause toxic reactions in the leaves. Of course, if you had a water analysis, we can sort of ascertain that way before we start using it and sort of treat or manage that water appropriately. Some of the leaf symptoms, for example, chlorosis, some of the yellowing of the leaves, whether it's the older leaf or a newer leaf. Edge necrosis or later leaf abscission if it's very uh, uh, high levels or high toxicities. And if you let it go even further, fruit drop can also occur. So leaf analysis will help you sort of manage that properly. Uh, so irrigation of olive trees, these two extremely critical periods during which soil moisture must be kept optimal for maximum production are at fruit set, which is generally around May or June, depending on the part of the state you're at. And again, oil accumulation, which is generally around August time or so forth. Those are the two critical points or periods that you must keep optimal amounts of moisture in your orchards. Okay, let's go ahead and discuss some of the growth stages and impact of water stress at the different stages of growth. So early on, beginning of the year, shoot growth, generally around February or so. Uh, Impact of water stress, whether it be too much or not enough water, is reduced shoot growth. So year after year, make sure and monitor how your shoot growth is, on your orchards. Make sure and make notes and how fast and how vigorous it is growing. Of course, not only water affects that, other nutrient toxicity or efficiency can help affect that. So make sure and jot down your fertility programs and just keep good records overall. Uh, at flower bud development is another important. If you cause water stress, that will reduce the number of flowers that will be uh, in fluorescence. Another stage is at bloom. Incomplete flowering can be a major problem as well. That affects overall production. Once that fruit set comes in, then, well, can you still affect your quality overall? Of course you can. Poor fruit set, just because you have a flower, it hasn't been pollinated yet, doesn't mean it's going to be set. So poor fruit set or increased alternate bearing. I've heard a lot of times that they say, oh, olive trees, it's normal to have alternate bearing, sort of like pecan trees. Well, not necessarily. Lack of moisture or lack of nutrients or timing of these nutrient applications can be of vital importance to sort of reduce or eliminate alternate bearing. Another important stage is at fruit growth stage 1, which is at cell division, is you can reduce the actual fruit size. So you guys that are sometimes complaining on different sizes, a little bit too small and so forth, and generally you see that in drought years because of that water restriction. But if you irrigate properly, that should not be an issue. Stage 2 is at pit hardening, so minimal impact on fruit size here. So not a major problem there, but it can contribute to overall quality. So stage 3, cell enlargement, it can reduce your fruit size as well, just as bad as stage 1. So make sure and monitor your soil moisture there. Uh, Oil accumulation, it can actually reduce your oil content. So you say, oh, I got my olives already set. I want to start cutting back down on the amount of moisture. Well, yes, you've got your yield there, but your oil content might be affected due to you cutting back on that moisture. So again, remember the two critical points, and that's one of them: oil accumulation, say in August or so. You got to keep optimal amounts of moisture in that major root system. Let's go ahead. Water management, of course, is critical for tree uniformity and sustained high yields, along with superior quality. Olives are, although considered drought tolerant, but they do not produce well without proper irrigation. So some of the literature states out there it takes approximately 3 acre-feet of water per year to be productive, which roughly translates to 977,000 gallons of water. Uh, Texas, I've seen out there some literature rule of thumb inch per week. Well, that can vary from the area, part of the state, whether you're in a drought situation, you've got a wet spring or a wet summer. So inch per week is not something I would highly recommend. But how can we measure that? So there's some other research that I was looking at here, or studies on oil quality that measured fruitiness, also bitterness, and overall pungency of this oil is produced at different water stresses by UC Davis. And there's the the publication information there. You can look up at a later time. But stress oils between 33 and 40 ETC produced oils that had better balance on pungency and bitterness, were pleasantly fruity, and more complexity and depth with high polyphenolic content, a lot healthier for you. High levels of irrigation lowered oil content, produced bland oils. Of course, the greatest water stress produced oils with excessive bitterness, high pungency, and woody herbaceous flowers. So, again, irrigation management of utmost importance, not only to yield, but also to quality and oil content and flavor over time. So, how do we evaluate a good irrigation program? Well, the most valuable information from soil moisture monitoring is obtained just before an irrigation and approximately 3 to 4 days after an irrigation. Assessing moisture prior to irrigation verifies that the soil has indeed dried out as expected. The evaluation of soil moisture 2 to 4 days after irrigation can determine the depth and the uniformity of the irrigation. See how good of a job we did, or how well we were able to push that moisture down there to at least a 2 foot level, to where the majority of your root system is. And of course, together they provide information confirming the root zone was refilled after an irrigation. Now, there are several methods out there that will help evaluate your irrigation program or overall. So let's start off with the field method first. And this is simplest, most subjective method. Samples soil directly with an auger and assesses water content by feel. There's some guidelines for relating feel of various soil textures to water content are available through USDA or NRCS. And here's an example of NRCS soil moisture determination by feel and appearance. And depending on the soil texture and the sample depth and so forth, and there's different concentrations or amounts of soil moisture that are required depending on how put that soil in your hand and you squeeze it, how much of a ribbon you build, or if it just starts breaking apart. So again, you can Google that estimating soil moisture by field and appearance by USDA and RCS, and you can read through that at your leisure. Uh, Another method is using tensiometers, which basically consists of a vacuum gauge connected to a piece of PVC tubing with a porous ceramic cup at its tip. So basically, as water is depleted, soil moisture tension increases. It creates a vacuum on that ceramic cup, which exerts tension on the column or of the water in that tubing. Of course, this tension is then registered in units of atmospheric pressure or centibars on that gauge. Of course, these a lot of these tensiometers, they provide these charts to help you convert 2% soil moisture depletion based on soil texture, and most valuable when two or three are placed at different depths in a single location. Again, location is important. So different soil types within the orchards are important. So you got to make sure and cover all those different variables when it comes to using tensiometers. Another tool is a electrical resistance block, or some people call it gypsum blocks or ceramic sand material, which contain two separate wires. The blocks are installed at different depths in the root zone using a device similar to a soil push tube. And again, highly recommend these at least at 1 foot and 2 foot level. So this handheld meter is used to measure the electrical resistance between the wires in the block. Of course, these readings are again converted to percent available water on those charts available provided by the manufacturer. The only thing here is soil salinity can influence readings by suggesting higher soil moisture levels than are present due to the salinity problems. Again, you're measuring resistance. Of course, we know salinity increases that resistance. So again, you got to be careful how you interpret a lot of these uh, uh, readings based on that gypsum block. Now, most of the orchards now that I've been seeing, or any row crops I've been seeing, is they use these soil moisture sensors, and they basically measure the volumetric water content on the soil. And a single probe can measure several depths, and I've seen some that go down as 3 or 4 feet and you can measure at 6, 12, 18, 24, 36, 48 inches at different times or intervals throughout the week. They can send critical alerts via emails or text or phone, but you must have a weather station nearby. And these are can get pretty expensive, but I think it's a good investment to take a look at over time, especially when it deals with the importance of moisture in your orchards when it comes to overall quality and yield in your operation. Let's go off into some soil testing basics first of all. As soil test is not useful without meaningful samples, and I can express how important it is to take a good a representative sample. And I've been out there several times when I see these consultants, or I've seen even fertilizer dealers that offer you this free soil test, and I've seen them where they get off the off their pickup truck on one turn row, get off, take a sample, put it in their sample bag, get back in the truck because it's maybe a little bit too hot, and drive away. Well, that one core and that turn row, do you think how representative that could be of the entire orchard? Not very representative. So you got to be careful and make sure you take a good regional composite sample. So how do we take a good sample? So you want to divide that field or management areas into, depending on topography, soil management, and so forth. Highly recommend going to NRCS website there, websoilsurvey.nrcs.usda.gov. And basically anywhere in the U.S. that you can get your soil types, percentage of that area, and so forth. And basically within the same soil type, you want to take 15 to 20 individual cores from the surface down to 12 inches and combine those cores in a clean container, something like a 5-gallon bucket. And as for trees, especially olive trees, they do feed at deeper depths, 12 to 24 as well. So I highly recommend doing a subsoil as well. Taking two samples, 0 to 12 and 12 to 24, keep them separate and make it two different samples. Make sure and clearly label the sample container or this soil bag. Make sure for any lab, include as much information from the field, how old those trees are, whether they're in production or not. Your last fertility program. You must remember that a lot of times we're a lot like doctors. You go to the doctor's office, they provide this history for you before they can ascertain an interpretation of those results. Any laboratory will be the same where any agronomist working with the soil analysis or plant analysis, water analysis, we really need that background information so we can provide the best interpretation and recommendation that we can give you. Different soil equipment you can use, of course, shovels. I like to use that narrow spade. It's very easy to get into. Your soil augers, these push tube probes as well. But if you're in a heavy clay, it's very difficult to take it with those probes. So I highly recommend using a spade or an auger. And you can find those anywhere online as well. Okay, so we start off good steps to take for a good soil test. Of course, sampling very important. Another thing is good, accurate chemical analysis from a good, reliable laboratory is of utmost importance. And again, like I said, there's what's even worse than not having good data is having bad data. So, interpretation of that analysis is very important. These analytical accuracy is essential, so make sure that your laboratory is relating these numbers to the actual crop response. Make sure they got some good, reliable removal rates that they can base on those results as well. Uh, are the fertilizer response predictions accurate for your soil types, your crops, and management practices? Make sure to provide as much information as you can to your laboratory. So here's an example of our soil test, which is an in-depth soil test, and this is one I would highly recommend from us or from any laboratory, which roughly includes your texture, and of course here this is from an olive orchard, and you notice we took two different samples, one from the top soil 0 to 12, and one from subsoil 12 to 24. Of course, we include your texture based on a rating 1 through 6. one being the sand and six being a clay. We do offer organic matter content as well. Your pH of importance. Have you noticed this one? If you only took the top sample, it was extremely acid, pH of 4.9 with no calcium, so we're actually recommending lime. But look at the subsoil. You actually have a neutral pH, 6.8, with high calcium down there. So early on, you might need some calcium to establish that tree. Applying lime applications maybe a couple of years. But after that, once that orchard is established, he has plenty of calcium down there deep in 2 foot level to maybe take care of the needs for that tree. Of course, uh, to verify that, a plant analysis would be ideal. Uh, Also recommend salts for salinity, electroconductivity to make sure there's no salt problems out there. Of course, they also provide your nitrogen, phosphorus, potassium, sodium, calcium, magnesium as well. Also recommend that soil tests include your micronutrients, for example, zinc, iron, manganese, copper, and boron. Now, this recommendation is for 5-ton removal rates on a productive orchard. And the far right hand side will have the recommendations there for nitrogen, phosphorus, potassium, as well as your micronutrients, zinc, iron, manganese, copper, and boron. So make sure to get a nice detailed analysis of not only topsoil but subsoil. Now, these are some nutrient requirements, uptake of olive trees that have been out there based on global research, some local reviews, universities research, and so forth at different stages of growth. So, some removal rates for olives, say at 3 ton per acre yield, will remove 45 pounds of nitrogen, 12 pounds of phosphate, 64 pounds of potash, and 5 pounds of magnesium. And generally talking, we'll have most orchards coming in at 3 to 4, maybe 5 ton yield requirements. Look what happens when you get up to that 7 ton requirements. Go up to 105 units of N, 28 pounds of phosphorus, 150 pounds of potash, and 13 pounds of magnesium. So you got to remember, if you want to go after those high yields, it's just not nitrogen that gives you high yields, but a balanced nutrition overall that will give you not only the high yields, but also a good quality of the oil after all. Here, plant nutrient availability based on pH. Basically, the ideal pH range for most nutrient availability in the soil is around pH around 6.5 or so. Of course, some areas you got a very high pH and very low pH. So you notice here that wider uh, bar for each of those elements, it's most available. Once it goes to the either extremes or narrow bar, it means that it's less available. Uh, uh, Fortunately, all the trees are can produce in a wide range pH, ranging from 6.5 to 8.5. Does that mean you can get optimum nutrition if you got a pH 8.5? Well, you got some nutrient deficiencies that will occur, specifically phosphorus and micronutrients. So we got to make sure and provide those if you got such a high pH problem in your soil. Sulfur, of course, in that situation would be of utmost importance. Now, leaf sampling. Leaf sampling is very specific because it gives you the nutrient content of leaves. Of course, can vary from location of leaf and tree. So make sure when you're taking leaf analysis, it's the same age of the leaf. Also makes a big difference. Younger leaf, of course, will test much different than the older leaf. So take 4 mature and healthy looking leaves from the middle of a non-bearing current season shoots per tree. Make sure it's exact same age, same variety, similar symptoms and location for each of the composite sample. So you take 4 leaves from each tree, and make sure and take from 20 to 25 trees representing a homogeneous plot of up to 20 acres. You want to make sure and rinse those leaves off with some drinking water or distilled water, blot them dry, and put them in a paper sack and ship those to the lab. Um, One of the questions that comes up a lot of times is, well, leaf analysis is great, but when should I do it? And most research out there, they claim or they stipulate that you ought to do one leaf analysis at fruit set. And to a point, yes, that is true. And all the data that they have is based on that one single sample, that fruit set. And yes, we want to know what nutrients do we need to fill up or finish up that crop. But I think is if you take one at bloom, say around April time, we can affect the yield overall because if you take one at fruit set, well, the yield's already set and we want to increase yield. So we got to make sure that we have the optimal nutrition at bloom or pre-bloom. So I recommend if you're going to do one, do it around bloom time. For an average program, for a good program, I would recommend doing twice or two samples. One in bloom or bloom time or pre-bloom around April time, and of course the other one right at fruit set. So that pre-bloom one will affect the overall yield. That will help us increase that yield, and that fruit set will help us fill out those olives. Make sure we got enough nutrients in there. Now, for the best program I would recommend is taking four times. I recommend starting at shoot growth, say around February when those February March when those shoots are growing, and let's make sure that we have enough nutrients that are going into those trees to eliminate as much stress as possible. Then, of course, at bloom time around April, at fruit set is the third one, and then the fourth one I recommend is post harvest around September October time. Why? Well, unlike deciduous trees that generally go dormant in winter, uh, olive trees do not. They continue working. They continue utilizing nutrients, albeit not that much utilized, but some is. And there are some studies showing that if we store enough carbohydrates in the winter or post harvest, that we get better production, better quality the following spring. So that's why I highly recommend doing that post harvest sample for that reason. So what do we get out of leaf analysis? Well, it shows the nutrients that are in the leaf utilized to date. Now, one thing that can sort of throw a monkey wrench in there is full applied nutrients are on the leaf can show up as an increased nutrient usage in that leaf. So if you don't provide a information to the laboratory that you just applied a nutrient foliar, then that could really skew the results and give you some wrong information. Interpretation of leaf analysis are based on relationship between the leaf nutrient concentration, growth, and yield. So comparisons allow this diagnosis of nutrient deficiencies or excess. Okay, these physiological processes are affected by leaf nutrient balances. So, following new leaves depend on the petiosap flow from optimum production of carbohydrates and other sensates. So, leaf analysis, of course, trying to help uh, uh, predict what the nutrient usage is and sort of help you find or detect the hidden hunger before those visual deficiencies occur. Because if you see those chlorosis or marginal leaf burn, maybe too late. It already affects your production. How much? Tough to tell, but some instances it can affect as much as 10%, 15%. How much is that worth? So again, leaf analysis can be of utmost importance as long as it is a proper sample. Here we are looking at a leaf analysis for a full program here. Uh, Actually taking four samples there on one variety, Arbequina. You can still will test their nitrogen. Tested fairly well all season long. Phosphorus, it started off really good, right to plume, and then sort of just plummeted down, say around April or June. And that could be indicating maybe a little bit too dry and not enough phosphorus getting into it, or maybe the phosphorus would apply too early and just tied up when we most needed that. And I'll be showing you here what nutrients are important, what stages of growth. Potassium again, real good all season. This particular olive orchard, they have some calcium magnesium issues because they've got some deficiencies in the soil they got to address. Zinc, essential for maximum genetic potential, was on target along with iron, copper, and boron. Some manganese deficiencies there are showing up almost all season long, so chronic manganese deficiencies there. Now there's some olive nutrient levels here, sufficiency ranges that it's out there that you can find that can be helpful, but again, you must know what you're looking at and make sure that you're taking the proper sample before these nutrient deficiencies can be used. Here, this is a seasonal nutrient requirements on olive trees. As you can see, nitrogen, potassium are the ones that increase the soonest. So February, March is when the uptake of nitrogen and potassium increases. Then phosphorus comes in around April or May when it starts increasing. So, this nutrient uptake also follows the water usage curve as well. Early vegetative does not require very much, but once it gets into the reproductive stage, that increased demands. So in this case, what happens if you put, for example, nitrogen, you put all your nitrogen early on, say around February, March. Well, you get a huge vegetative growth, and that will affect, have issues going into reproductive stage because excess nitrogen says, hey, I've got plenty of nitrogen and I want to go and grow and grow and grow. Well, that will affect your production because your bloom set will be minimal, your fruit set will be minimal, and then you've got also disease pressure coming on because of too much shade on that tree. So you got to make sure and spoon feed that tree accordingly to the time of the year it requires it. Uh, not only the fruit tree, but look at these changes by organ. Look at the flowers or pre-bloom. Leaves of sort, of course, naturally start using those nutrients earlier by shoot growth, but then now you got the uptake of organs at bloom set. So now the increase starts demanding as well, not only leaves, but your flowers. Then you go into reproduction stage and set your fruit. Then now you got more demand on that fruit later on this season. Uh, so recommend some soil application fertilizer early on soon to help with the shoot growth. But mostly fertigated or spoon feed that early on. And the ideal time to do that is say around May or June. Now there are some people or sometimes that we do recommend foliar applications, and those are the times we highly recommend in May, June, July. And I always hear sometimes, well, I've done applications of so and so and foliar and never got a response. Well, start asking more questions and come to find out they did it too early or way too late, or the wrong chelation of products. Product is of utmost importance. Make sure, I highly recommend amino acid chelates, ideal. The other thing is, when you do any foliar sprays, highly recommend them early in the morning or late in the afternoon. Why? Well, that's when their stomata is open, and that's the only way it's going to get into the leaf through the stomata opening, and that's when they're most open, early morning or late afternoon. Now, just because you have the proper amino acid base doesn't mean it's going to get into the plant. If you get in the morning, if you check your water, remember I talked about having hard water. You get your foliar application, you apply it, and that water's so hard, the surface tension will just hit the leaf and roll off the leaf. Well, it's not going to get into the plant that way. So again, do a water analysis, make sure you soften the water. Ideal pH ranges say around 6 to 6.5 for foliar spray. So if your pH is 7.8, most likely have high bicarbonate, you'll have to acidify that water. Highly recommend use of surfactants or stickers as well to help you increase that. So a lot of times, a lot of people that just don't have faith in foliar sprays is because some of those instances they just timing is off, wrong product, or the water is a major problem as well. So talk about these foliar sprays and so forth, and let's talk about some of the nutrients involved in olive production. Let's start off with nitrogen or synthesis of proteins. Some of the symptoms of nitrogen deficiency, of course, is the small yellowish leaves. Usually occur in the older leaves first. You see poor shoot growth early on uh, in the growth season. Of course, a lack of water can also help you that. Again, leaf analysis will help determine that for you. Sporadic blooms as well. Not all uniformity will be occur, and of course, poor fruit set can occur with lack of nitrogen or nitrogen deficiencies. Uh, Phosphorus again, it's used for cellular division and formation of energetic structures. So some symptoms of phosphorus deficiency similar to those of nitrogen deficiencies, such as small leaf size, but without the leaf deformity. You also get that sort of red leaf type color on the leaf, and of course that can also can be contributed to so very cold temperatures can affect, but generally, depending on the state, the area, the state you're growing, generally not an issue. Light green leaf tips as well can be symptoms of phosphorus deficiency, or very dark green emerald color also can be a problem with of course, vitally important at flowering and fruit. Remember, I showed you that fruit organ chart. Make sure if you're going to put any phosphorus, it's at that stage growth of vital importance, if needed, of course. Potassium, utilized for transport of sugars, helps regulate the stomata. Cofactor of many enzymes, also reduces ability to plant diseases. Uh, you heard earlier about possible problems with scale. Well, we have seen where you've got some optimal levels of potassium in trees, and you got some good prune trees. Generally, scale is not as bad, or may not even be an issue. Some of the symptoms of potassium deficiency, of course, occur with light green leaves, generally on their older leaves, because of the translocation to the newer leaves. In severe cases, you see that tip burn. You can see there on that slide, the margin sort of looked like an inverted V on the tip burn. You get dead areas and necrosis on the leaves. And on chronic issues of potassium deficiency, you get twig dieback. I see a lot of that issue sometimes on just your little twig. It's just very severe zinc deficiencies. Of course, it can reduce your fruiting and contribute to small fruit size. Talked about earlier about controlling stomata. So we have found if you keep at least a 1-to-1 ratio, same amount of nitrogen you do potassium, it really increases your overall water use efficiency. And we have seen almost to 70 to 80% increase in water use efficiency when we apply potassium. And there's some studies there here where we use some low potassium and normal plate potash irrigated drought. We can see the increased use of water simply by applying some potassium if needed. Calcium, one of the major building blocks in cell water, and reduces susceptibility to diseases as well as potassium. Uh, some of the calcium deficiencies, of course, chlorosis on leaf tip, similar to boron. Veins in chloritic area older leaves become white. Of course, poor growth shoots and roots. Unlike boron, there's lack of young shoots. And again, vital at flowering and fruit set. So make sure you get some calcium. I always recommend, if we are recommending calcium, always apply some boron in there. It helps sort of transport that calcium better into your crop. Magnesium, it's a central part of chlorophyll molecule for photosynthesis. So, some magnesium deficiencies occurs chlorophyll leaves that begins from the top or the edges. Some severe leaf shedding from generally your older leaves inside the canopy. Poor vegetative cycle, and of course, again, vital at fruit enlargement. So make sure, if needed, based on your leaf analysis, make sure you get some magnesium there at fruit enlargement. Some trace elements also record small amounts: zinc, iron, manganese, copper, boron, moly. Some of these deficiencies or elements can reduce growth and fruiting, uh, and commonly associated with low pH, less than 6, and high pH, greater than 7 soils. For example, boron utilized for cell wall, germination, elongation of pollen tubes. Also participates in the metabolism and transport of sugars or carbohydrates. Some symptoms of boron deficiencies you can see there: round terminal bud turn light green, a tip, and fall off. Later growth shows small and distorted leaves. Sometimes you'll see a little bit of cupping or irregular growth on the leaves. Dropping of buds or blossom, poor fruit set. So again, essential of bud development. Make sure you got enough calcium, boron in there. Sometimes calcium as well. I did find some studies there where it says a post-harvest spray accounted for 80% of boron used spring buds. So again, that post-harvest leaf analysis I highly recommend. If you happen to be deficient in boron, having a boron application post-harvest will contribute to next year's buds formation, so of utmost importance. A zinc deficiency. Zinc is a black growth, promotes auxins or synthesis of auxins, enzyme activation. Some of the zinc deficiencies, yellow spots may appear on adult leaves and small pale green leaves. Interveinal chlorosis, some similar deficiencies to iron and manganese, but essential at bud development. We have seen that post-harvest applications lifted bud levels in the spring, improving development and survival as well. Iron chlorosis synthesis, some of the iron deficiencies, yellowing of young leaves, mid-rib and veins greener than inner vein areas. Fruit tends to be pale yellow rather than green yellow. Again, vital at fruit enlargement. Manganese, also necessary for photosynthesis processes. Some of the manganese deficiencies, interveinal chlorosis, flower buds often do not fully develop, turn yellow or out of abort. Again, vital fruit enlargement. A lot of these micronutrient deficiencies is very difficult to identify unless you've got a keen eye to identify them. So again, leaf analysis will help you determine which of these micronutrients deficient and causing those chlorosis. And again, ultimately, you want to do the leaf analysis before these deficiencies occur. Uh, Here again, copper influences the metabolism of nitrogen and carbohydrate production. Most common on sandy soils, on leaf rosettes and pale yellow white leaves as well. Other trace elements, moly deficiency is rare, but more likely in acid soils. Nickel required by urea enzyme in plants, often efficient conversion of urea to ammonia, rounded on blunt leaf tips or rosette, may lead to dwarf tree organs, delayed bud break, reduced energy storage by trees. Generally not a major problem. Uh, this last year, we've been doing some research in other crops, specifically when it came to sugar beets, wheat, and potatoes with silicon, which we're calling the ultimate stress reliever. It's not only a as a soil application, a soil conditioner. It's also an anti-stress bioregulator, and overall structural component of the leaf and the soil. So outside the plant, it impacts soil structure. We have found that you have saline soil conditions. It can help sort of improve percolation of your water and soils, thus providing better moisture and oxygen to your roots. It impacts overall fertility. It sort of helps control, enhances the uptake of the nutrients as well. Inside the plant, it affects the plant structure, growth, and development. So it really helps with that. In soil, helps stimulates microbial growth, beneficial soil bacteria and fungi to help sort of protect against any soil pathogens. Increases biotic stress. For example, fungal infections reduced, take no longer spread. We have found that where we have optimal levels of silicon, that leaf is a lot thicker and it really helps against any fungal infections or even piercing insects. If you have aphids or any of these other issues, it can help control that. Helps deter insect pests as well. There's some studies showing that some chewing varmints like possibly deer or even rabbits don't like the metallic taste of silicon, so they won't go after that plant. Overall, more tolerant to abiotic stress such as drought, excess moisture, mineral balance, extreme temperatures. So it's we have seen some tremendous results. So have not tried it on olives yet, but I highly recommend. I think we've seen this on a number of crops. I think it will work very well on olives as well. Again, overall, we're trying to eliminate as much stress as possible off the orchard by trying optimize the amount of moisture that it comes to when it comes to your orchard at the key physiological stages of growth, as well as nutrition. Nutrition plays a vital role. Early on, when shoot growth doesn't require very much moisture or nutrient, but once it gets into the reproductive stage, they vamp up. You got to make sure that we keep enough moisture on those orchards, and we keep enough nutrients in there as well. So, just to recap, overall, olive fertility, olive trees can be an efficient feeder under ideal soil conditions, but most of those time, ideal conditions are not always available. Nitrogen, phosphorus, potassium are the main elements which must be applied, but most often calcium, magnesium, zinc, manganese, copper, and boron are greater needs. Of course, some of these trace elements don't require very much, but they are important. Pounds of actual nutrients per year are dependent on tree size. Again, early on, when those trees are growing first couple of years, I only require about 20% of the nitrogen, 30% of the phosphorus, and 20% of potash, and maybe less than 10% of the micronutrients recommended. But once they start in production, then we need to start increasing those nutrients. Some of the prevailing deficiencies in Texas are most often potassium and boron. Again, how do you verify that these are some of the deficiencies in your orchard? Leaf analysis will tell you that. Fertilize in fall to aid in fruit bud development, and the spring when new growth begins. Additional fertilizers may be added according to as the plant or leaf analysis this season. Uh, so make sure and do some leaf analysis to help you manage your fertility program. So this is TPSL's proprietary Ask the Plant program, which helps in-season adjustments to maximize your plant's genetic potential. There is my contact information. Again, we're in Edinburgh. There's our phone number, my email. You got any questions, feel free to email me, give me a call. Those are our websites, texasplantandsoillab.com and asktheplant.com. In fact, on asktheplant.com, you can find some sampling instructions for olive leaf or sampling, as well as some information on nutrition on olives as well. If you got any questions, feel free to give us a call or give us an email. Off the top of my head, some of the common uh, questions that appear are, as you know, the timing of the application of these fertilizers of importance. Again, uh, say late vegetative to early reproductive stages when we must have those nutrients, and those times I highly recommend. But again, a soil analysis and leaf analysis will tell you exactly uh, uh, times that are required. Silicon example, they're asking what kind of products you recommend silicon. Well, there's several products out there in the market. There's some calcium silicate products, some potassium silicate products, and those are the two primary products that contain silicon. And we have found where we've got a combination not only injected into their irrigation system, but foliar applied have been the best or ideal amounts of silicon. On those, I highly recommend at least 3 to 4 foliar applications seem to do the ideal or best. Again, potassium silicate or calcium silicate. I guess it depends on your leaf analysis. If most of you guys, if you have a calcium deficiency, I would lean towards a calcium silicate. If you're seeing some potassium deficiencies, I would lean towards a potassium silicate. Just depends. Again, a leaf analysis will help you that. If you have any questions, feel free to give us